Antibiotics are misused, it can lead to them suddenly not working anymore. And if you ask folks like Richard Dawkins and Bill Nye the Science Guy, the answer is that this is incontrovertible proof of evolution right before our very eyes. It's an evolutionary arms race, they say, and it's true that antibiotics do sometimes stop working, and antibiotic resistance is a form of evolution, narrowly speaking. But is this a demonstration of the creative power of Darwinian evolution, or is there something else going on? Let's take a look more closely. There's a lot of ways for antibiotics to defeat bacteria. Some explode it, some come off the works, some starve the little bugs out, others prevent them from multiplying, and so on. But there's essentially only one or two ways that bacteria can become resistant to antibiotics. The first and most common way bacteria gain resistance is that it's always been there. Antibiotic-resistant bacteria actually pre-exist the invention of modern antibiotics.
That's true, but it doesn't disprove evolution by natural selection. When a small minority of a population has a trait, but the environment changes and that trait becomes dominant in the population, that is a prime example of natural selection.
There's an interesting story of some Arctic explorers from back in the 1800s. Turns out they froze to death before the discovery and use of antibiotics. Some morbid scientists found them recently and took samples of their gut bacteria and found that they already had resistance to some of our most powerful modern antibiotics.
This article is from 1988, so it's not exactly up to date on our newest versions of antibiotics, although the creation of new types has slowed down. According to the article, the bacteria were found resistant to types of two different antibiotics, which were developed in 1970 and 1978.
Those drugs are still used today, but this still does not disprove evolution. According to the scientists who discovered the bodies, the men died from lead poisoning, and the scientists suspected that the large amount of lead in the area might have resulted in the evolution of bacteria that were resistant to antibiotics.
If that's true, that's actually an example of evolution occurring, because the bacteria are developing a new trait because of natural selection due to a change in their environment.
Just like some people are naturally short and immune to limbo bars, some bacteria naturally have a pre-existing resistance to antibiotics. Not because they've gained this ability after an encounter with the antibiotic, but it's just always been the case. That said, bacteria do have a neat special ability that short people don't have. They love to share. Not just cooking recipes and financial advice, but super personal things like their very own DNA. They'll swap loops of DNA called plasmids in a process called horizontal gene transfer, or HGT. They have no idea how they got them or even what they do, but they'll trade them back and forth, and occasionally, they'll share these resistance genes. Nothing new has been made or evolved though. Bacteria already had the ability to trade plasmids, and the genes for resistance already existed before antibiotics.
Horizontal gene transfer is a real process that is a major way for bacteria to spread drug resistance, but this doesn't disprove evolution. In fact, it's an example of it. Gene transfers are random, but the bacteria who acquire drug resistance via a gene transfer will be more likely to survive longer and reproduce more, so eventually a larger part of the population will be drug resistant. Exactly what Darwin claimed would happen.
This is hardly an arms race, and it's not a demonstration of Darwinian creative power, since there's no new mutations and no new genes that have been made.
That's not necessarily the case. There could have been a mutation for a drug-resistant trait that then spread to the entire population via HGT. The fact that HGT happens does not mean that a mutation didn't.
Not only that, but these extra resistance genes are frequently a net negative on fitness. Bacteria with extra useless genes tend to be less fit than regular old vanilla bugs. Imagine you're in a foot race. You usually don't need a duffel bag filled with camping supplies, a pickaxe, spare bowling balls, and a weed whacker during your typical foot race. If you do, great. Otherwise, it's a huge waste of energy lugging all of that stuff around, and it makes you less competitive.
This, again, is true that more genetic load makes you less fit and therefore less likely to survive in some environments. However, Darwinian evolution depends on the environment, and in an environment where there are antibiotic drugs that are trying to wipe out the bacteria, a minor difference in fitness doesn't matter.
If we borrow his analogy, carrying a duffel bag with a weed whacker and a pickaxe might harm you somewhat in a foot race, but it will probably help you if you're being chased by a serial killer, which is essentially happening to the bacteria.
Bacteria with extra genetic load tend to be less fit than regular old vanilla bugs.
What about mutations, though?
This is the second less common, but more interesting way that bacteria develop resistance to antibiotics.
Whether or not it's the most common way bacteria develop resistance or not doesn't matter. If bacteria can develop resistance to antibiotics via a mutation, then that proves Darwinian evolution can happen, which is the entire underlying premise.
How does it work? Scientists are aware of pre-existing resistance. So to exclude it as a possibility in experiments, they can start with a single normal, non-resistant bacteria and let that multiply over and over again, and eventually the bacteria population can still develop resistance on its own. Here's how. When copying their DNA, organisms are pretty accurate and mutations are relatively rare, but given enough time, errors do sneak in, like typos or autocorrect when you're texting someone. Sometimes they're no big deal and you can get along in spite of them. But sometimes these mutations really do something and can confer resistance or even immunity to antibiotics. Amazing, that must demonstrate the mighty power of evolution. Well, hold your horses. It's sort of like someone who has no arms saying that they're immune to handcuffs. No legs? You're immune to toenail fungus. No teeth? Congratulations, you're immune to cavities. Think of how much you'll save on toothpaste and floss expenses. Deaf and blind? You're immune to getting annoying songs stuck in your head. Wow. This poor soul might technically be immune to those things in a perverse way, but it comes at a cost. He's hardly a more fit organism, and these mutated bacteria are just hobbled, busted up versions of the original. Darwinian evolution can't get very far by breaking things. Eventually it'll run out of things to break. And in reality, when antibiotics are removed from the environment, these superbugs just sort of die out, because without the help of the antibiotics keeping the stronger, normal bacteria at bay, they can't compete and they die out.
This is a common devolving argument that is not solely confined to this video, but it does not prove a thing. Darwinian evolution depends solely on the trait which is best fit for its environment. In an environment with antibiotics, having resistance is best because you won't die. Without antibiotics, resistance isn't as important, so the bacteria will die out. This is exactly what Darwinian evolution predicts. Organisms will adapt to their environment via natural selection.
This is why the analogies he's using don't work. If you're being chased by a serial killer, things like having teeth or not being 100% fit aren't helpful unless they will help you get away from a serial killer, which is what those antibiotics essentially are from a bacteria's perspective.
Those are the two ways that bacteria can resist antibiotics. Okay, forget about antibiotics. Let's look at the experiment that Darwinists always point to show evolution right before our very eyes. The granddaddy of bacterial lab work, Richard Lenski's long-term evolution experiment. In this famous experiment, Lenski has simulated in the lab, over the course of a few decades, more than 1 million years of evolution with bacteria. Since humans and other large organisms can take years or even decades to reproduce, it's difficult to see any change between generations happening in our lifetimes. But smaller microorganisms like the bacteria E. coli can reproduce in just minutes, letting us observe tens of thousands of generations and the changes that go along with that in real time. This is what Lenski has done for the past quarter of a century or so. Just let a bunch of E. coli bacteria reproduce and watched what happened. Pretty soon after the experiment began, he noticed that they started to grow much faster than normal. Then, a while later, Lenski's E. coli suddenly gained a new ability to eat something new called citrate. This was an earth-shattering find in the world of evolutionary biology. Scientists were swooning in the streets. To hear them tell the story, this was a huge new evolutionary leap, proving beyond a shadow of a doubt the power of random mutation and natural selection.
The video is making this sound like this is the only experiment that has ever been done for evolution, but that just isn't true.
But would you believe it if I told you there was a problem with this explanation as evidence for the creative power of evolution? True, there are at least 3 problems with this explanation. What exactly happened to cause the E. coli to grow so much faster? Well, they broke their flagella. What is that and why would it make them grow faster? The flagella is a little outboard motor of the bacteria. It helps them move around and do their thing. But Lenski's bugs were in flasks that were swished around constantly, allowing them to get nutrients without ever having to move. They were spoon-fed lazy bums. This usually vital part was not currently needed, so it was a waste of energy, and they got rid of it. It's like selling the wheels off your car when you're at a stoplight. You'll save a lot of gas that way, sure, but you haven't really made a better car, and it'll sort of be a problem the next time you need to go anywhere.
This is essentially the exact same argument as before, but it still isn't correct. Darwinian evolution depends solely on the environment. This bacteria's environment did not require it to move, so the bacteria ended up evolving to become much better for its environment. It might not be good if it needed to move anywhere, but in this environment, it didn't need to move anywhere. So, the evolutionary processes don't care about whether or not the bacteria is able to move.
Well, what about the citrate thing? It's gotta be obviously true that being able to eat a brand new substance is a good thing for these little fellas. Like if we could eat dirt or something. Imagine the possibilities. Well, to make a long story short, all of the complex genetic pathways and proteins needed to transport and metabolize citrate were there all along. Not only that, but E. coli also already had a sophisticated mechanism to turn this ability on and off depending on its environment, so that they could prioritize their optimum food source, glucose, and not waste energy. All that happened was that the sophisticated control mechanism, the switch, broke. This bacteria lost the ability to turn off an ability that they already had. Now it was stuck always on, wasting energy to try and transport and metabolize citrate even when it wasn't necessary.
Metabolizing citrate was useful for their environment, so it definitely was not a waste of energy.
It's sort of like this alarm clock. It has the ability to make this lovely noise. It's a nice ability, but it can be turned on and off. But what if the alarm clock was broken so that it made that noise forever and could never be turned off? Much better, right? Right? How can this not be a win? Sometimes it's good for your alarm clock to make noise, but it's very good to be able to turn it off too.
However, if you never got out of bed when your alarm clock rang normally, you would want it to ring nonstop. That's what Darwinian evolution is, adapting to your environment.
E. coli could already do a thing, and they were broken so that they did that thing constantly.
But they weren't broken. It was the best trait in their environment that helped them survive the longest, so over time it became the dominant trait.
Maybe you call that evolution, but Darwinian evolution demands innumerable new genes, new proteins, new body plans, new organs, and complex characters that we see in nature.
This is only one example of Darwinian evolution, and it's a pretty short-term one at that. But despite that, this process did actually produce a new dominant gene and new body plans. Obviously, you can't have organs because they're bacteria.
This is not that. It's equivocation, using language so ambiguously that it misleads. For example, Aristotle was Greek. Greek is a delicious kind of food. Aristotle must have been delicious. Evolution has so many definitions that it's sometimes difficult to pin down what is meant by it.
Evolution is a very complex topic with many different definitions depending on what you're talking about. However, all of these definitions have the same core idea, that over a period of many generations, or even 1 or 2 generations, a species can change and even create new species.
One could mean a shift in pre-existing populations, like Darwin's finches or peppered moths, or breeding or cultivation, like dogs or plants. But these are miles apart from extrapolating random mutation and natural selection can build new organs or body plans, or universal common ancestry, zucchini are related to tuna fish, which is even further apart from the wild claim that it all happens strictly through materialistic processes. Darwinists equivocate when evidence is presented to prove one definition of evolution, where there is evidence and everybody agrees, and then another definition is quietly swapped in based on wild extrapolations to hoodwink people who aren't paying close enough attention. To extrapolate from antibiotic resistance to the larger kinds of changes evolution would need to make new animals,
evolution does create new animals. It isn't very common because it can take millions of years for new species to evolve, but we can observe the creation of new species right now in the real world. Here are some species that have evolved recently.
This is an example of the microevolution versus macroevolution argument creationists often use. They will agree that a species evolving a new trait, microevolution, happens, but deny that this can yield entirely new species, which is macroevolution. These are not two distinct processes. Microevolution causes macroevolution.
There might not be a major difference in the short term, but over the long term, you will end up with very different species.
It's kind of like saying, last week, this cow could jump 1 foot high. This week, she can jump 2 feet high. Doubling at that rate in just 30 more weeks, she'll be able to jump clear over the moon. It's a bad extrapolation. There's a hard limit to how high cows can jump.
That's true. If antibiotic studies were our only evidence for evolution, it would be foolish to extrapolate that back over millions of years. However, it isn't our only evidence. In fact, we literally have fossils that show evolution extrapolating back millions of years.
And there's a hard limit to the time and populations available to evolution, and to the number of features bacteria can break before running out of things to break.
Evolution involves species adapting to their environment, as stated earlier. If losing a trait or mechanism is beneficial toward an organism, it will adapt to lose that trait.
Darwin didn't write a book called How Pre-Existing Organisms Break Themselves. He purported to explain how novel species came about from a single common ancestor. And at least as far as this is concerned, it was a failure. Darwin can't get very far by squandering pre-existing genetic information. Darwin's mechanism creates variation largely by throwing genetic information overboard and selecting for damaged or broken genes, blissfully unaware that it's marooning itself on an island of genetic fragility, making organisms, ironically, less able to adapt in the future, thus hindering larger scale changes from accumulating. There's an old joke that perfectly summarizes what's going on. Wow, you're so rich. What's your secret to becoming a millionaire? Oh, it's easy. First start with $1 billion and then light a bunch of it on fire.
This is still the same devolving argument that is essentially a major cornerstone of this video.
Bacterial evolution is lauded as a premier example of Darwinism in action, as Dawkins puts it, before our very eyes. And actually, it is. It doesn't demonstrate Darwinism's creative power, though. Instead, it's a perfect demonstration of Darwinism's impotence.
No, it isn't. As we've shown throughout this video, it actually supports Darwinian evolution. Bacteria adapt to their environment.
But even if we assume that antibiotic resistance disproves Darwinian evolution, it still doesn't disprove the cornerstone of Darwin's theory, that species evolved over time to get us to where we are today.
Darwinian evolution is only one of the many mechanisms that can result in changes to species and even new species created over time. Creationists like to focus only on Darwinian evolution because Darwin lived 150 years ago and thus had a more basic understanding that didn't involve modern science. So Darwinian evolution is easier to debunk, but that doesn't mean that it gives you the full understanding when they do those debunks. In summary, this video mostly just repeats a bunch of creationist talking points and does very little to actually disprove evolution, Darwinian or non-Darwinian.